Welcome to the Houdini 20 Feathers preview. If you know SideFX, you know we don't do this very often, doing a preview before the launch, but it's an area that Kai is just so bursting with excitement to talk about that we wanted to reveal it here at FMX. Kai is based in Germany. He's one of the I guess the only developer in Germany, right?
Well, no, we have Esther.
Oh, yeah, of course. Well, on the Rican side. So Esther and Kai. And Kai has been focused on developing this feather system for quite some time now, and we're excited to reveal it here today. So over to Kai Stavginski. Kai.
Very good job. Thank you. Thank you for that nice introduction. Yeah, I feel kind of privileged because I think it's definitely the first thing we're showing about Houdini 20. So, and you're kind of privileged. So, yeah, let's get to it. Yeah, like you said, I've been working on this for, I guess the last thing I actually released in Houdini was in 19.0. So it's been a while. But yeah, it's a big project. What you're going to see is actually probably like version 2 or 3 or something of this. So I probably started over like 3 times to get it just right, and I'm talking a lot to our customers to like kind of listen what they really need out of this, and yeah, hopefully this is the result of that. Yeah, let's get started. So it is, feathers are one of the most frequently requested features that I hear for sure within the kind of creature space, right? Everybody seems to be doing feathers right now. Like there's a huge demand for it. We just, I just did a tour of our biggest customers in London to talk feathers, and everybody wants it. Another team within SideFX went to up and down the West Coast, I think, to talk feathers, and it's just everybody needs to do feathers. So, of course, yeah, a lot of our big customers, they've all had to make a feather system already, right? And there's a lot of experience, so we have a very tight feedback loop with our clients, and so there's a lot of existing experience to draw from. So yeah, I really put a lot of focus on that with this project. Yeah, we're also having 2 of our most other frequently requested features with this release as well. One of them is texture mask painting. I have to put the emphasis on mask painting because it's not supposed to be like a Mari competitor or something like that. It's supposed to be, you know, it's supposed to service grooming tools and things like that that need, you know, relatively simple scalar masks painted. It's not supposed to paint colors. And yeah, we have much improved guide interpolation. That was a fairly common issue that people faced that need a lot of just hand-holding to get just right. Yeah, let's talk about the scope of this within Houdini 20. So first of all, there's a feather primitive. I have that in quotes because it's not really a primitive type. You'll see how that works later. With the focus on efficient storage and efficient rendering. So this is really, that first bullet point, there's a lot packed into that. It's really about, well, all our customers are telling us it's just a pain to do feathers because it's just so heavy, right? Like if you saw Gabriella's talk yesterday, she was talking about 120 million points, and it just becomes painful. So it's trying to address, like trying to enable people to work with that kind of detail while not suffering so much. Then we have the feather design tools, like to make your individual feathers, right? We have the grooming and shaping tools, so taking those feathers and putting them on the bird and setting up orientations and everything that's needed there to get a coherent kind of groom onto a bird. Procedural processing, so you know the kinds of things you know from grooming in Houdini already, like clumping, but now focused on the individual barbs on the feather, creating the typical splits you see in feathers and noises, all those kinds of things. And then more advanced procedural tools like de-intersection. So feather de-intersection and that kind of feather packing is one of the toughest challenges with feathers. And whenever I talk to customers about it, it's especially customers that are doing feathers already somehow, they're asking us to solve this problem for them, right? So we're trying to do that with this release as well. Yeah, skin adherence all kind of plays into the same thing. Then driving that with vellum simulations and rendering via Solaris Procedural. So there's going to be a USD Solaris Procedural, basically built around the idea of writing out one rest frame, full detail groom, and then deforming that with polygon surfaces. And yeah, also part of this release are just a lot of general grooming improvements. Yeah, so this slide is also the outline of my talk. I'm just not ready to talk about vellum simulation and the procedural in detail, but that doesn't mean it's not going to be in the release. It will be. Yeah, so let's work down that list. So I'll start with the feather primitive. So this is, the talk in general is kind of a broad overview, but to explain this stuff, I have to get a little bit technical if you're not that interested in that, or some of the things don't make sense. That's not that important, but it'll be interesting for anybody that has to, implement some in-house tools based on this. I'll get started with that anyway. Yeah, so I really thought long and hard about how we can make feathers a lot more efficient in Houdini, and the basic idea with that is we can exploit the very well-defined, well-known structure of feathers, right? There's a lot of data there, but we know that a feather is like one main curve, the rachis, with a bunch of feathers, a bunch of barbs branching off. So there's this idea in Houdini 20 that you don't have to store an actual curve primitive for each of those barbs, because there's a lot of redundant data, right? We know if you have a point on your main curve, we know there's going to be a pair of barbs branching off. So what we actually do is just store some attributes on the main point to that is then used by the GPU to draw the barbs, but we don't need to have an actual curve primitive for each barb. So that saves a ton of data. Yeah, these are the actual bullet points that I just talked about already. I just added this slide because when I showed this presentation internally, I was asked what was the actual hardware that I used. So it's 13th gen i9 with fairly normal GPUs, not even a 3090 or anything like that. So nothing exotic or too out there. Yeah, so with that, let's jump into these feather primitives. So what you see here is a bunch of like low resolution, fairly simple feather designs. And you see me switching a display mode. So the first one that you see here, where it's all just a single curve, is the data that Sops and Houdini, or the operators that work on the data, actually see as topology, as geometry, right? It's just a single curve. And then when the barbs appear, it's literally just a display option. And what's happening underneath is, well, that data is stored, so it's there. It's ready. It's a separate attribute that's ready for you to manipulate however you want. But the display of that is only happening on the GPU. So there's no like vertices, vertex data, vertex lists, all that stuff that has to be stored. Otherwise, that's all kind of virtual, right? If that doesn't make complete sense yet, I'll go into a bit more detail about that. So here's just a visualization of what that data kind of looks like. So every point on the main curve has a position, which you see on the left there, and orientation, quaternion orientation. And when I rotate that point, it's really only manipulating that one orientation attribute. And the fact that the barb rotates with that point is just because the GPU draws it that way. So the GPU reads that array of data that you see on the right, which is the position of each point along the barb, and just rotates it by the data on the point. And one really great benefit from that is, as I do that, and as you do things like sculpt that main curve to just move the feather around without like modifying the barb detail, The barb data is just sitting on the GPU. It's not even uploaded to the GPU again. It's just ready to be drawn again. So there's a lot of efficiency to be gained from like splitting that main curve and the barb detail into separate attributes. Yeah, there'll be, like as I go through the actual tools, you'll see a bit more of how that data structure actually works. But now we're getting to what I call the system building blocks. So these are kind of things that are, they form the part of the feather system as a whole that we're building in Houdini 20. But they're also supposed to be building blocks for you guys, yeah, for anyone who needs to build a feather system within Houdini that maybe they're just, it's a big space to explore, and like you could have very different approaches within Houdini 20, just thanks to the flexibility of Houdini in general. But these are the kinds of things that could be building blocks for any feather system, even if it's an in-house custom one, right? So I'll start with a fairly basic example. That's the feather resample sop. So because each feather is actually only a single curve, and the barbs are like data on the points. Imagine the barbs are just like a color attribute, just with multiple points. You can have a very easy resample of where you change the count of the barbs by just, you can actually just use a resample sop, but we have a feather-specific one that just takes care of some details about the feather, like not moving that first barb point, so it kind of resamples within the space, within the part of the curve that actually has barbs. Then here we have a bit of a combination of nodes. So again, I'm using the resample to get a low-res version of my high-detail feather. Then I'm using the feather surface sop to turn that into a polygon surface, setting up some simple attributes and running a basic vellum sim. And then to bring that back onto my feather representation that I just talked about with a single curve, I just use the feather deform sop, which can do, it treats the deformer polygon surface as a subdivision surface, so it gives you really nice, high quality, really smooth deformation very easily. And that feather deform sop is going to be the base of our Solaris procedural. So that's probably all I'm going to say about that in this talk, but it's essentially that just. So within Solaris, you'll bring in your rest room, you'll bring in these surfaces that are vellum simulated or not, or they're just bound to the character mesh or whatever. And the procedural will deform in place and in memory, and you don't have to write, you're not going to have to write the groom per frame to render it. Yeah, here we have the feather uncondense sop. So I'm calling these single curve feathers condensed feathers. It's kind of I wanted to come up with a new term that's distinct from packed primitives because it's not a packed primitive. It has a lot of advantages, but it means that, you know, to manipulate the barb data, a sop that wants to manipulate barb data has to be aware of those kinds of attributes of that structure. Feather uncondense is a way of avoiding that, so it's able to expand that data to real curves. So you literally just get a real curve in Sops. When I display that, you can see more points appearing. That means you now have real curves, right? So if you wanted to do something like array some feathers onto a height field or something random, there's never going to be array feathers onto height fields feather specific sop, right? But you can do that with the existing tools. If you go feather uncondense, you just do it there, and then you can go back to the feather representation with match uncondensed. So here I have the expanded version, and with the match uncondensed, I can transfer all the changes back to the efficient, you know, GPU drawn representation. So you can easily jump out of that system. And when I gave the system to an artist recently to design some feathers, he used some of the tools that I made that are feather specific, but he also really wanted to use just, you know, guide process and things like that on the barbs. And a lot of people I know use the hair clump sop to manipulate barbs and things like that. That's still very easy to do. You just jump out. Having said all that, it's also possible, of course, to manipulate the barb data directly. So you don't really have to read the code there, but it's basically a very simple wrangle sop that imports, works on each point and brings in all the barb data for each side as an array, loops over each element in the array, and just scales it by some value that you expose as a parameter. So it's not hard to like work on that directly, and doing that has a lot of benefits, right? You don't, if you don't have to expand to real topology, it's just all a lot more efficient. Here's an example where I do the same raycast onto a height field, all without doing the uncondense. So you can do that as well. It's just a bit of vex. So there's a chain of 2 Sops here. The first one just works on the main curve, which already gives you like 90% of it, but it's not actually adjusting the barb shape to the terrain. And the second one is a little bit more involved. It gets the array of barb values and then rotates it by that orient attribute that I showed earlier, adds on the shaft position to kind of transform the barb into object space, because otherwise they're stored in kind of a local space of the feather. And then it does the ray and transforms it back. So yeah, it's a lot more efficient. So yeah, for a TD experience with Houdini, it'll be very straightforward to write tools that work directly with this without having to jump out. So the way, let's actually jump back. The way I envision this is you might use the uncondense for like quick one-off things, but if you find some workflow that you use all the time, you probably want to write some tools that don't require that. Yeah, here we're getting into feather template interpolation. So feather templates are basically your designed feathers that you intend to put on a groom. Here we just have 3 different ones. I colored them in RGB just for visualization. And then we have a bunch of curves that would be your groom curves. And these just have an orientation attribute, and they have these arrays of data. There are going to be many tools to put on these arrays and change these arrays, but it's basically each curve has yeah, a list of templates that it should get, and a list of weights. So you can say for each curve, this is a mix of, you know, wing feather and some covert feather or something, and the template interpolate will then grab all the barb data from those templates, sample it onto each curve, and mix the values, right? So you can see them interpolating here. And here we actually have, so jumping over to a completely different way of displaying feathers, we also have kind of a real feather primitive, but it's really just, it's very similar to a crowd agent primitive. What I'm doing there is basically binding the geometry to a very simple skeleton where you have a chain of joints along the shaft of the curve, and you can also have branching joints at certain intervals along the curve. And this feather instance pool, what it does is actually analyzes what blends of feathers you have within your groom, and creates like a specified number of samples within that space. So let's say you had a very simple case where you had 2 different feather types and they're just blended across. What you would end up with is something like this, where you have you know, one primitive for each template, and then a bunch of steps where they blended in between, and those are then instanced where they're wherever they're closest to the actual blend you have in the groom. So that makes it extremely efficient for as kind of like a way of displaying the full groom as you groom. You'll see how that works. I'll have a bit more detail about that. So here's a closer look at what the joints look like that are generated for these primitives. And a lot of the tools, like the feather deform sop that I showed earlier, they'll just take both forms of feathers. So either you'll have the single curve representation with the barb data, or this, and deforming this type of feather just means setting joint positions, right? So it's incredibly efficient. And again, the deformation actually happens on the GPU. All right, yeah, that's it with the basic building blocks. Let's jump over to designing a simple feather. So with these tools, yeah, I really wanted to focus on making viewport-based intuitive tools for this kind of stuff, like getting away from the typical ramp interfaces that you see in a lot of tools. I just wanted to be able to, you know, take a photo reference image and just draw some curves on it. And then you have a collection of procedural tools that, that are able to generate the barbs and generate the feather from that. Yeah, and here you see me using the second input of that node to add some profile curves. So you can place those curves wherever along the shaft and just give them some shape, and the barbs in that area will do exactly what those curves are doing. And then the in-between barbs basically just interpolate those shapes right there, a smooth blend. So that gives you a lot of, like, I think, very intuitive control. In a lot of cases, you'll see that those kind of splits that I'm creating at the end there, they might be added procedurally. But if you're working on something like a, you know, highly visible, large wing feather, you might want to do it manually, like specifically like I'm doing here. All right, let's jump over to grooming. So it's basically taking those templates that you design and actually putting them on. So the idea with grooming feathers in Houdini is to really just extend the tools that are already there to respect and, like, be aware of the orientation attributes that I talked about. And in this case, yeah, so what you're seeing here is each feather is, again, a single curve. So a lot of the tools that were already there, like the sculpt tool, they don't even have to know all that much about that. They just have to update, like if you sculpt the curve, you really just have to update the orientation attribute. And the end result is, it just feels very natural to work with feathers in the grooming tool, right? You're able to see the shape of the feather right within the tool. But it's still, you know, it's not like an overwhelming amount of data. So as you do the basic sculpting, you know, the rough grooming, you don't really have to, there's no extra data to manage or anything. It's just basically assigning the feather template to each feather and doing the blending, and then adding orientation. You know, here I'm just brushing over the feathers to tilt them a little bit so they're roughly aligned. We also have separate tools to do this, the intersection stuff, so it's not really about that, but it's just as quick to do this initial feather groom as it is to do a fur groom, until you get into the more, you know, where the feather stuff gets complicated with the intersection and packing and all those things. So here I'm just painting on a different template, right? It's just, there's a paint template tool, you pick the template from the list. You can also select it from that, you know, if you have them laid out in one geometry, usually you do, you can pick it from the geometry. It's all very intuitive. Here's another groom example where I'm adding some head and body feathers. So really just the same thing. And you see, yeah, it's not drawing curves because you just turn on a feather display option and you're working with feathers, right? And then here's a look at the new guide interpolation method. There's a later slide where I'll get into more details with that as well. But you'll see, if you're familiar with how the guide interpolation worked before, it looks probably very foreign. It used to be that, yeah, you had this idea of an influence radius around each guide, which, you know, if you had varying density of guides or across the groom, like you needed a lot of guides on the face, and then you kind of want a sparser set of guides on the body. You had to do a lot of tweaking to get the interpolation just right. Like you might have had to paint the influence radius or vary that across the character somehow. And so the main kind of innovation with this is you can have like one guide on the head, one guide on the tail, and all the hair that is generated in between will kind of do something that makes sense. There'll be a linear interpolation across. And, but still, like, as you add more guides where you need them, it's easy to add local detail as well, right? So it's a nice blend of sparsity, so you can get away with a lot fewer guides than before, I think. But you still retain the ability to add local detail. Yeah, I could say more, but there are more slides that go into more detail with this stuff later. And sticking to grooming here, we're back to actually displaying the groom using those agent primitives. In this case, we're actually looking at fully detailed, high resolution, like render quality feathers. I think there's like 2,000 of them, and grooming them in real time. So the way this works is, I didn't really want to add that stuff to the guide groom. The guide groom SOP still just deals with curves. So it just outputs the curve plus the orientation and the template information, you know, which curve is which template and which blend of templates. And then there's just an output node that, you know, a feather deform that puts on those instance pool things. And here I'm painting on a different template type onto the groom. Just in this case, it's just literally stored on the groom curves, right? And you can see that smoothly blending across. You know, at that point you have a blend of templates, and that all works quite smoothly as well. All right. Let me check the time. I have no idea whether I'm like fast forwarding or... Yeah, I think we're doing okay. I'm not going to need the whole hour, by the way. There's time for questions. Yeah. But it is what it is. That's what we have so far. Let's jump over to procedural editing. So there's more to grooming, but you'll see more details about that later. But this is basically taking the output of a basic groom, putting the actual barb data and everything onto the curves, and then doing some things like adding these procedural splits to the barbs. And here you also see me doing that using the new texture paint SOP. I'll get into more detail about that. Like I mentioned, that's actually probably the most highly requested feature we have for grooming, is just being able to paint textures right within Houdini. And here you see me using the feather clump and feather noise SOPs. For the noise, I'm using kind of extreme parameters just so it's very visible what I'm actually doing. So yeah, just taking any attribute here, I'm just taking the noise amplitude and painting a texture for that. Right? You'll also see that these groom overrides, these parameters with the drop-down where you can pick what the parameter should be overridden by, they've really been expanded for this version. So you have ramp parameters right within the override now. It used to be that a lot of the subs we had like a specific separate ramp to drive certain things, but now every override has that, right? So it'll make those nodes a lot more flexible, and I think there'll be many cases where you can save like a dozen wrangle nodes that you had to set up before to drive these things. Yeah, here's another example where with the feather noise, where I'm painting another attribute, this fall off parameter. So the fall off is kind of how strong the noise is along the length of each barb. And it's a parameter that requires a certain range of values. It's not like a 0 to 1 normalized thing. So previously it was kind of a pain to work with when you had to paint attributes. And just the simple addition of this fit parameter where you can take an input range from the texture and then remap it to the values that make sense for the parameter, all within the node, that makes that a lot easier. So here I'm varying the fall off between like 2 and 8, and it's just very simple to set up. So the areas that are painted white are remapped to the value of 8, and the 0 areas in the texture are mapped to 0. All right, let's talk about intersections. Yeah, this is where feathers get really challenging, I think. So hopefully we can solve that for a lot of cases. This is the result. Well, no, this is the input to the feather de-intersect sop. It's terrible. Yeah, so you input something that's fairly terrible, just no regard for resolving intersections at all, right? Everything's just intersecting. And this is showing its kind of automatic mode, where it does all the steps that are required. So there's this first step of finding the order that the feathers should be in, right? We have this idea of a primary and a secondary sorting direction. So primary would be feathers that are behind one another have an obvious sorting, right? So a feather that is like closer to the head is usually on top. So that one is actually fairly easy to do procedurally. But then defining an order for feathers that are side to one another, next to one another, you tend to need a little bit more input for that. So there are various ways of defining that. Yeah, you can do that. The simplest way is to do it based on a position attribute. So basically, as the feather is further away from the origin on the x-axis, you regard that as being stacked below the feather with a lower value. So that, you know, as you go out on the bird, the feathers are below, and you can reverse that. And I think I have an example of that here. So yeah, in this case, you can see the middle red feather there is on top, and the ones next to it are below. And you can just change that with simple change of parameter. And one very important thing that you'll see with both of these examples is, it's actually not that visible here, but it doesn't just, yeah, it like push feathers apart. It can actually compact the feathers as well. So if they're initially far apart, it'll compute some stacking that makes sense, right? It sorts them and compacts them so they stick together, which is very important, especially on body feathers. Yeah, like we saw in Gabriella's talk yesterday. It's just a very important aspect of the look to have this closed feather surface. So you should be able to get that out of the sop. So I also have a kind of smaller scale example of just like what actually happens to the individual feather within the sop. So what happens here is there's a predefined order, right? So the fact that the kind of mustard-colored feather is supposed to be in the middle, that's set up front, so it doesn't just decide that. So it just does its best to kind of resolve that. And you can see kind of as I slide in the feather, the others start to adjust, and it's all kind of a smooth thing. So you can imagine that happening on the whole groom. Yeah. You'll see here I'm kind of visualizing what happens with a few iterations of this. It's not supposed to keep on jiggling, so I'm still working on that, like a convergence of that. But it's important to say that this is not a simulation, though. So it's not like a vellum-based approach, and it doesn't require like a DOP network. And that's going to be important going forward because I eventually want to turn this into a brush tool as well. So, you know, a lot of times you'll only want to do this in certain areas, and it's kind of difficult to set up. Even when you have a procedural SOP that does it, you have to paint maps and everything. So I'd like to just have it in the grooming tool, and it'll be a lot easier if it isn't a simulation, right? Yeah. The goal will be to kind of move this forward in the process. So as the groom is made, it'll be a lot easier to have it non-intersecting from the start. This is an issue that clients have told us about, that a lot of times when there's not a lot of time, you'll end up showing clients grooms that are like not that clean, and you'll maybe get approval on the groom, and then as you go into simulation, you realize, well, maybe it's not going to work as well as you thought, and you have to de-intersect it then, and it changes the look, right? So at that point, the approval might just be void. So moving that forward in the process and making that easier, I think is going to be very important. All right. Now we're getting to just hair grooming improvements in general. I think with a lot of the things I've shown, you can probably tell they're directly applicable to hair grooming as well. Well, I just want to show some more of those things. So let's see some more texture painting. Here I'm actually just switching to wireframe mode to prove that I'm painting something that can't be represented with the topology that's there, right? So, so far in Houdini, you've had kind of two choices with this kind of thing. You could use one of the like topology-based paint Sops, like the attrib paint, which relied it could only put as much detail there as the topology allowed, right? So oftentimes you had to kind of subdivide the topology just to paint certain attributes, or you could go out to like a third-party application and do the texture painting there. That becomes kind of painful as well because the feedback loop is just not that great. So yeah, I think I wanted this like 3 releases ago. I'm just really happy we have it for this release. Yeah, and like I said, you know the kind of parameters in the grooming system that have these overrides with the dropdown. This will just be an option in all the dropdowns. So wherever you were able to bring in a guide attribute, a skin attribute, a texture, you'll be able to bring these in. And the way they are, so what this actually produces within Houdini is a 2D volume primitive, just like the height fields. You can see that texture paint Sop there in the network, and the second output of that is literally just that 2D height field. So yeah, that also makes it very very friendly to more manipulations on top of the painting, right? It's right there and ready to be manipulated by wrangle nodes and VOP networks and whatever you want. So the texture might actually only be the first step to that. You can bring it over to COPS, do image manipulation. Maybe there's some, MLOPs that you want to plug into that and do some machine learning based generation on the texture. It's all ready for the taking, I think. Here, I just want to show the guide interpolation stuff in some more detail. Again, this is just adding, like, you can see a very sparse set of guides, and it's doing linear interpolation between. You can see I'm literally creating like a dozen guides maybe, and I have the flow. I'm not paying too much attention to what it actually looks like, but you can see you can define the flow across the whole bird in like a few strokes. So let's jump into what that actually looks like underneath. So it introduces another input on the hair gen node. So that has 4 inputs now. And the 4th input is for the separate mesh that is only used for the guide interpolation. And what you see here is there's this guide interpolate Sop, guide interpolation mesh Sop that generates a very low res version of the character mesh that you put in. So you can define the resolution that you need. You can usually get away with, you can get away with very few points usually. And you'll see that wherever there's a guide, there's a point in the mesh at the root of the guide, right? And that point is basically weighed 100% to that guide. So it means any hair that is generated within the vicinity of the guide will do exactly what that guide is doing, which was, with the old method, was sometimes kind of difficult to achieve, like to get that very localized detail. Here you can see that, those points at the root of each guide. So now they do that, right? Now the hair that is right at the guide will do exactly what the guide is doing. So you get a lot more, groomers just get a lot more control. The guide interpolation mesh, the node that generates that mesh, also uses texture inputs. So here I'm painting one texture, that is used both to define where I want the hair to grow, and the guide mesh SOP can use it to generate the mesh only in that area, right? I only need that mesh where I have hair. So this is actually not the best example for it. If you imagine like a human character and you just want to paint some eyelashes on it or something like that, that whole process is super efficient with this workflow, because you paint a small area with one high-res texture, the mesh is only generated there, and it all happens very efficiently. So you can have a 1 million point mesh, but create hair in a very small area very efficiently, and the performance doesn't degrade just because there's a lot of mesh surrounding that you don't really care about. Here's an example with an actual just fur groom. So you can see the hair. What might be kind of weird if you know the previous approach, you can see as I draw the first guide, you can see hair appearing everywhere, and it's just grown wherever you painted the texture before, right? So that's a new requirement, that you add the texture to define where you want the hair to grow, but it's very easy to do. And here, the ears are a good example of the hairs just doing exactly what the guides are doing. And you know, previously the first guides that I scattered across the head, they were very far apart, but then you go into a smaller detail and add a few more densely packed guides on the ears, and it's just the flow kind of makes sense everywhere. And it's much more, you know, you go into certain areas of the character and see where more detail is needed rather than like fighting the interpolation. Yeah, and here's just a closer look at what those parameter overrides look like. So yeah, you've got the fit, the ramp, and that drop-down that has the edit entry for texture primitive. So the texture one, we had that already. That's where you pointed at a file on disk, and the texture primitive is usually from that new fourth input that is added on most of the grooming Sops, where you bring in one of those 2D volumes. And that's it. That's what I have so far. So yeah, like I said, I didn't need the full hour. There's time for questions. Yeah. Please. Hey.
Yes.
Oh.
Hold on.
Yeah, we'll get you as well. Sorry.
Thanks. Hey, Kai.
Hey.
Yeah, that's looking really exciting. So we've just done a feathered bird in a show that we're working on at the moment, and we were using one of the third-party feather systems.
Yep.
And one of the issues that we kept running into was when we decided we needed to go back and change the underlying model.
Yep.
We tended to then lose all of the groom that we had done. We would kind of have to redo it, and we ended up rolling back to the original guide groom version 1, I think, that had the recache button.
Oh yeah. Okay.
So is that going to be an issue with the new system?
No, well, yeah, so the recache SOP is one way of doing it. It does have its limits though, right? It's not going to solve every problem. Like we have the, sorry, we have the guide transfer SOP, which does that, like as long as the, like one thing, like the UVs or the topology stays the same, you can transfer a groom, right? And one of my plans for Houdini 20 is actually to make that like a one-click thing within guide groom. So at the moment, you end up just, you can do it, but you end up with a messy network where you have a guide groom, you do the guide transfer, you can do another guide groom, keep grooming, and maybe even delete the other ones. But I just want it to be a button within guide groom. And yeah, recache, I was hesitant to get rid of that, but you know, our customers are telling us like in production it just doesn't, beyond a certain point it just doesn't scale, and they're telling us, yeah, it's there are very few. There's like a small percentage of grooms where you can actually use it effectively. So I don't think it's the solution going forward, especially as the grooming tool gets more advanced. You struggle to kind of store all the information that each stroke actually requires, right? Like imagine you select a few hairs and do a stroke, and you do that 100,000 times a day. Each stroke would have to store the selection that it used, and it just explodes. So yeah, I think it'll be more like a procedural approach, like the guide transfer. Yeah, there was a question behind. Yeah.
If you want to do some effects like wet maps, for example, having an animal that's wet, how do we get the information of object to feather transfer
Right.
like in our textures?
Yeah, it depends where that information lives, but if you have like a point attribute on the skin, this is probably the most straightforward way. You can, I mean, to just get it onto the skin, it could be like an attribute transfer that you run within a kind of Sops solver to keep the history information. So you add each frame, right? And then to get it into the grooming system is very straightforward. It's using one of those parameter overrides that I showed. So you might have like, or you might do it like, maybe you design a whole dry bird, you design a whole wet bird, and you have like a blend in between, and the blend can read, you know, wherever each feather sits on the skin, it reads that point attribute information. So those kinds of things are pretty straightforward with the system, I think.
Okay.
One of the things first of all, I wanted to clap like a number of times during that talk. Like,
Thank you.
Individual, like the ramp fixes with the fitting and
Yeah.
stuff are like amazing.
Yeah.
Take a giant crappy network and turn it into like a tiny, so awesome work on that. One of the things that was really interesting about Gabriella's presentation, I think yesterday, was just the texturing of the feathers.
Yep.
And I noticed you had a lot of textured
Yeah, I
feathers
love that.
there. And we didn't really get to see kind of how that's
Right.
working. Are you giving like UVs to the textures that you're then reading? Are you like can you talk a little bit about that?
Yeah, so first of all, yeah, I just want to copy that.
Yeah, I mean, it
Gabriella
made a
has.
ton of sense. It was really nicely done.
Yeah. Yeah, in this case, the artist that made those feather templates, I should have talked a little bit about that. He just had like a big reference photo with all the feathers laid out just like you see in my scene. He designed the feathers just on top of that, like I showed. He did use that basic approach. And then he did, I'll get to your question, I just want to talk a little bit more about the approach. So he did use the feather uncondensed to jump to the actual curve representation. So you could use guide, process, and all the kind of after feather stuff at the bottom of the feather. He did that with just guide, process, bend. But when you create the feather, it actually adds UVs to the points. So the UVs are stored just like that barb array of data. So that's necessary because as you move the barb, you want the UV to stick, of course, so it has to be stored. It has to be an attribute as well. And that's how that works. And what I don't have yet, but I want for the release is like a way of transferring attributes just from a polygon surface. So you could have a grid that has your reference image projected on it, and you just transfer the UVs from that to the feather, right? So you just get a match with the texture. So yeah, it's easy to add UVs. You can also have the barbs can also have per point color, so you can add any number of attributes you want to that barb data, right? So you can. That's what Gabriella is doing. It's just point colors with that pattern generator, and it would be quite easy to make that same thing for this kind of data representation.
Other questions?
Hi, I just have a question about, I guess, portability. I think one of the issues with hair and feathers is that everyone has been building their own, and they're all different, and they all can't be transferred easily.
Yeah.
So you talked about, at least in probably Lab Solaris, right, passing it through as a render procedural. But are you thinking about an open feather source that could be used anywhere so that people could actually use it wherever they need in the pipeline?
Yeah, so the way that the data is kind of represented is intentionally very simple, right? There's not necessarily like a grand design to make that open source like data format or anything like that. But yeah, it's a point plus an orientation plus like a list of position values, and it's definitely it's like extremely suitable to GPU drawing and GPU processing, and it's also very easy to like the type of array for those barb values can be directly exported via Alembic, And then, of course, it's up to other software to support that type of data, but it's very straightforward. Like, we have a pretty good relationship with, and a lot of back and forth with Epic for the Groom export. And I think eventually they'll also support this kind of thing. I didn't go into too much detail, but if you just have fewer points on the shaft and like a few barbs distributed along, you can switch it to a surface drawing mode, right, where it draws polygons. And I see that as a way of exporting to game engines for sure. You know, render the high-res feather, bake that down to a texture, and then map that onto the polygon surface, and you're nearly there. Yeah. I hope that answers the question. Like, there.
Yeah, that's good.
Anyone else?
So the untangle layering of feathers that you have going on, which is super cool, how would that work in combination as a post-process after animation, after simulation, right, whatever the case is? Says it seems like it's kind of settling down and popping into place.
Yeah. It's definitely intended as a like preconditioner to a simulation, right? So that's the focus for now.
Is there a plan to do a post-process version of that that can do it after simulation?
Yeah, not a well-defined plan. I think the the idea is to make it easier for Vellum to deal with the input, right? Like Vellum is usually, if the input is quite clean, Vellum is usually pretty good with that. And at least the customers I've talked to, they're telling me Vellum is probably one of the things they worry about the least with this whole space. But yeah, I do get this question a lot. There are different opinions on how this should work as well. Gabriella was talking about doing a tetrahedra simulation, like treating the feathers as kind of a fat layer type simulation where you just add jiggle. That has a really nice property in that feathers that might be intersecting in the input, they stay in that configuration. So if you have like two feathers that are just crossing through each other, because they just move with the tetrahedra, you don't have them traveling through each other, so they don't pop visually, right? If they had different textures and suddenly one is on top of the other, that's where you really get into trouble. So you can get around that whole problem to some extent that way. Yeah, but for now, I think we'll rely on hopefully really cleaning up the input to the Vellum sim and then Vellum keeping it clean during the simulation.
No one else has a question. I have a question.
Yeah. Take the mic though. Oh, yeah.
You mentioned that you have a render procedural for Solaris, if I'm not mistaken, for this to draw all these secondary curves.
Yeah, I hope to. I don't.
You hope to.
But,
okay. But for a studio that doesn't use Solaris as a primary renderer, it will probably be possible to bake all these curves out somehow.
Yeah.
Yeah.
Yeah. I mean, with Solaris, there's a bunch of nice things that you get, but you know, the deformer is going to be fairly straightforward as well, and it's going to be an OpenCL. The code will be there. I encourage you to have a look. But yeah, I'll talk a little bit about more about how that works in Solaris. So USD has a concept called prim adapters, and that's going to enable us to, without you doing anything, when you render with a renderer that supports this stuff, like it has to be specifically implemented, right? We can just send the main curve with the data to the renderer, and the renderer will generate the curves. There's no renderer that does that now, but that'll work. And when there's a renderer that doesn't support that, so it can set some flag, I don't know what this is, then the procedural can automatically expand that to real USD curves, and it'll still render correctly, right? Yeah, you don't get that, but yeah, the usual approach would be you just do the deformation wherever in Houdini and write it to disk, that the brute force approach, or you have a deformer procedural wherever you need to render, right?
Yeah,
From a feather blending standpoint, because it's just data that's then got, an array of points, it seems like you could have pretty easily like a feather blend node. For one issue that we run into a lot is the closed wing requires kind of like a completely separate groom that you're blending to. Is that kind of in there by default, like some sort of like
there's
groom blend or something that works with the feather data?
Not yet, but that's a good point, yeah. There's the template interpolate, which does a more complicated thing. So it'll be quite straightforward to take that and that same algorithm and do that. So feather template interpolate, I didn't mention, it can blend between different point counts as well, and it handles that gracefully. With this case, you don't even have to do that, right? It's just like literally blending the template data. And sometimes it might be enough to just blend the orientation attribute, right? So you don't touch the actual intricate detail, you just blend the orientations and do it that way.
Yeah, I mean, in our case, I think we'd be doing the orientations plus another de-intersect probably on that closed wing shape.
Right, yeah.
Which would need then the barbs blended.
Yeah.
Okay.
Maybe one more. And if not, then we'll say thank you, Kai.
Thank you.